Okay, so we're skipping the do now. Let's go and just review the properties of the parallelogram. We're going to mark them and we're also going to write them out in words. So someone tell me one property of a parallelogram. Michael. You got it. So we know opposite sides are parallel. So PL and AR are parallel. PA and LR are parallel. Someone tell me another property of a parallelogram. Simon.
Opposite sides are congruent.
You got it. Opposite sides are congruent. So we have that PL is congruent to AR, and we have PA is congruent to LR. Right, another property of a parallelogram. Sam.
Opposite angles are congruent.
What angles?
Angle P congruent, angle R, and angle L are congruent.
Good. The opposite angles are congruent. Perfect. Opposite angles are congruent. So angle P, the big P, is congruent to the big R. In a proof, would we be able to write P and R? No. How many letters would I need to use to name these? 3. I'm just letting you know because we're calling it big P and big R, but in a proof we couldn't write that down. We'd have to name it with 3 letters. And then the big A is congruent to the big L. So that is opposite angles are congruent. Right, another property. Julia. Excellent. Let's put a point E in here in the middle. Let's put a point E. The diagonals bisect each other, so that means that AE is congruent to EL. And I'll just put a circle this time. PE is congruent to ER. Do you all remember that circle is just another mark? It's like adding a slash. That's all that circle is another tick mark. So here we'd write down diagonals bisect each other. And you could put EO for each other. Okay, one more property. It's not really a way to mark this property, but there is one more property. Maya? Not all the angles are sub. The ones... Good. Does anybody remember what we call the angles next to each other, Livy? Consecutive. So we're going to say consecutive angles are sub. All right, so those are the 5 properties of a parallelogram. It says, let's prove some of these properties. No, thank you. Let's not prove any of these properties. No, no, no. Okay. All right, let's go on to number 1. Let's go where it says other proofs. Okay, so we are given that we have a parallelogram. It says ABCD is a parallelogram. When you're given that we have any of the quadrilaterals, you are allowed to use any property of that quadrilateral that will help you solve the proof. So I told you we have a parallelogram. Doesn't a parallelogram have 5 properties? We could use any one of those or multiple of those properties to solve this proof, whatever helps us. So we'll keep that in our head. We know that ABCD is a parallelogram. There's 5 properties that we can use to help us. Then it says angle GHA, so follow your letters, angle G to H to A. I'm going to call this angle 1 right here. Angle 1 is congruent to angle FEC, which I'm going to call angle 2 right here. Then we have that HB is congruent to DE, so I'll mark that. And we need to prove, I'll highlight in yellow what we want to prove. We want to prove that GH is congruent to EF. GH congruent to EF, is that a property of a parallelogram?
No.
No, it is not a property of a parallelogram. Since it's not a property of a parallelogram, and clearly there's no reason right now we should be able to say that GH and EF are congruent, what do you think the game plan is going to be? What is it always?
Proof triangles congruent.
Prove triangles congruent. So we're going to prove triangles congruent and then hopefully CPCTC, GH, and EF. Do we agree on this game plan? All right, so I think it's pretty obvious the two triangles we're going to use. We're going to first try to get triangle FEC congruent to triangle GHA. All right, so let's use properties of a parallelogram to help us. Now, I don't know if you guys see this, but I definitely see this. Do you see this Z right here? Yeah. And I see the armpits of the Z. Let's call them angle 3 and angle 4. Now, I can only get angle 3 and angle 4 congruent because of the Z if what? If what are parallel, Libby? Good, if the arms of the Z are parallel. Right now, are the arms of the Z parallel? Did it get stated anywhere? No, but isn't ABCD a parallelogram? And in a parallelogram, aren't opposite sides parallel? So I can start off by saying that, step number 2, DC is parallel to AB.
So we have to list the properties we use in the proof.
Uh-huh. So we're going to say that DC is parallel to AB, and your reason, this is how you're going to write all your reasons for the quadrilaterals. You're going to name the quadrilateral. What quadrilateral do we have this time that we're using? So you start off by writing parallelogram, and you could shortcut it the way I shortcut it, 2 parallel lines and then ogram. Remember, that's not parallelogram. It's just the parallel lines and then ogram. That's how I shortcut it. All right, then you draw an arrow. So parallelogram yields, and then you name the property that you used. What property did we use? Opposite sides are parallel. All right, so now we named that the opposite sides are parallel. Now we can go on. And now I can say that angle 3 is congruent to angle 4. Who remembers how we write this reason? Why am I allowed to now say 3 is congruent to 4? Mia? Right, what do I have to put first? You're right, that's the second part.
Parallel lines.
Yep. Parallel lines yields alt interior angles congruent. You got it. So now I have two angles. Do we all agree we have 2 angles? We need a side. We need a side to get these triangles congruent. Go back to our given. We had that DE and HB are congruent. Do those count as sides for these triangles? No. It would be nice, though, to get EC and AH congruent, right? Because then it would be angle, side, angle. Anybody have any ideas on how we can get EC and AH congruent? Vincent?
Opposite sides are congruent for parallelogram.
Good. So Vincent's getting us started here. So in a parallelogram, opposite sides are congruent. So which sides do you think I would declare congruent? Livy? Good. We would say DC is congruent to AB. So step number 4, DC is congruent to AB, right? And how do we write down the property? You got it. Parallelogram yields opposite sides congruent. How does this help us? Somebody who's not Vincent, tell me, how does this help us? Because now we have the full DC congruent to the full AB, and from the given, we had DE and HB congruent. How, Tanya? Excellent. We can use subtraction. So now I can say that EC is congruent to HB subtraction. So now I can finally say the triangles are congruent. So step number 6, triangle EFC is congruent to triangle HAG. Angle, side angle. And then we can CPCTC what we need. GH is congruent to EF, CPCTC. I'm sorry?
Is it gonna like depend on the problem for most of these?
It's gonna depend on the problem.
For step 5, is it supposed to be like EC congruent to HP, or is it AH?
Oh, I wrote that wrong. Thank you for catching that. Guys, I wrote the wrong segment. It's EC congruent to AH. Thank you for catching that. All right, we ready to try another one? Yes? Not yet? Okay, sorry. Do you not have a stylus? Are you a freshman or a sophomore? I think, didn't we say one of my styli work for the freshmen? I think this one works for the freshmen.
It doesn't work.
I have.
Try on everything. Those don't work.
What happens if you connect it with Bluetooth?
That one's not Bluetooth.
Oh, it doesn't?
No.
Try it. It's this side.
Yeah.
All right, let's keep going. All right, so now we have a rectangle. There's 2 different ways to do this proof. There's a long way and a shorter way. I'm going to show you both ways, okay? There's a long way and a shorter way. I'm going to show you both ways. We're going to start off with the longer way. So all we're given here is that we have a rectangle. But that's actually giving us a lot, right? Because that means I can use all the properties of a rectangle to help us out. Now, what is it that we want to prove? I'm going to highlight and then I'll erase it so it doesn't look too complicated. But we want to prove that triangle DEC is isosceles. The way to show that a triangle is isosceles, you have to show 2 sides congruent. You're going to have to show 2 sides congruent. So we're going to have to show probably DE and EC congruent. All right, that's our game plan. Don't mark it because I'm going to erase it. But do we all agree that's ultimately what we want to do? All right, well, should we do the shorter way first? I'm going to do the shorter way first. Because if you remember what I've been stressing this whole time, what is so special about a rectangle and its diagonals? All parts of the diagonals are congruent, right? Didn't I say like this was the telltale sign that it's a rectangle? Right, but now it's about how do I transfer this, like these markings, into written in a proof? All right, well, we got to go step by step. So we're going to name our first thing about a rectangle. And in a rectangle, the diagonals are what? Congruent. But is AE a diagonal? No, AE is not a diagonal. AC is the diagonal, right? So I'm going to say AC is congruent to BD. And then our reason, this time we're not going to start off by writing parallelogram. What am I going to start off by writing? Rectangle. So we're going to say rectangle. Sure.
Can you draw it?
I don't want you to draw it, no. Rectangle, arrow. And then it's going to be diagonals diagonals are congruent. So that gives us this whole yellow diagonal congruent to this whole green diagonal. So because the diagonals are congruent, what makes us get them all four parts congruent? What else do they, so the diagonals are congruent, that's an extra special feature of a rectangle, but there was something from a parallelogram that led us to this. Okay.
AC bisects BD.
AC bisects BD, and so AC cuts BD in half, but also BD
Oh yeah, BD bisects
AC. Don't the diagonals bisect each other? All right, so step number 3, we have to write that down. We're going to say AC bisects BD, and in the same step, I'm going to say that BD bisects AC. They bisect each other. All right, how am I going to write this property down? We're going to say rectangle, arrow, diagonals bisect each other. You could just put EO for each other.
I need to keep my eyes on the board.
The properties.
Sorry.
Okay, so here's the part that I think would stump you. This is, or I'm guessing would probably stump you. So we got the full AC congruent to the full DB. We have that the diagonals are cutting each other in half, right? But now I actually have to state that they're congruent. So my step number 4, and in this, and ultimately when I'm trying to prove DEC isosceles, do I care that all 4 of them are congruent, or do I only care that DE and CE are congruent? I only care that DE and CE are congruent. Is it wrong if you say all 4 segments are congruent? It's not wrong. You can if you want to. I'm just going to say that DE is congruent to CE, but now we need a reason. Now we need a reason. Maybe?
Is it definitely bisect?
No, so the definition of bisect would get DE congruent to EB. And then separately, it would get AE congruent to EC. So that def of bisect wouldn't help us. But I know we haven't seen it in a while. Double bisect here. What do you guys remember when there's double bisect, double trisect, double midpoint? Julia? You got it. Multiplication or division. Since the full segments are congruent and they're both being bisected, meaning divided into 2, if the full segments are congruent, are their half segments also congruent? Yes. If the full segments are congruent, their half segments are also congruent. What is that? Division. That is division.
Could it also be multiplication if it was like the other way? Like this, when you have double bisect, could it be multiplication or division?
Yeah, so if I gave you the half segments, then we could have gotten the full ones through multiplication. All right, now that we show DE and EC congruent, can we now say that it's an isosceles triangle? Absolutely. Triangle DEC is isosceles, and that is def of isos. All right. Because I don't really think that would have been your course of action if you were doing this problem on your own. Let me show you the longer way this could have been done. Let me show you the longer way this could have been done. You like this way?
Yeah, bisects are hard.
I feel like the division part would have stumped you.
Now that you're reminded.
Yeah, now that you're
Now, okay, good. Can I erase this work to show you? Yes, no, maybe? Anybody still copying? Okay. So let me show you the longer way. All right, the longer way we could have done this is, again, we still need to get triangle DEC to be isosceles. We still need DE and CE to be congruent. But I'm going to go and I'm going to do it through proving triangles congruent. And do you all see angle 1 and angle 2 here that I labeled? My goal is to get angle 1 and angle 2 to be congruent, because if I get angle 1 and angle 2 to be congruent, can I do base angles to legs? All right, that's my game plan. So how am I going to do this? Well, I'm going to get a pair of overlapping triangles congruent. What overlapping triangles am I talking about? Oops, let's do pink. ADC. That triangle, and BDC. All right, is angle 1 a full angle in the purple triangle? Yeah. Is angle 2 a full angle in the yellow triangle? Yeah, absolutely. So now I'm going to use properties of a rectangle to help us get these triangles congruent. Who knows a property of a rectangle? Who can remember a property of a rectangle? Any property that can help us get these two triangles congruent. Michael? Excellent. All angles are right angles. So I can say angle ADC and angle BCD are right angles. So angle ADC and angle BCD are right angles. And this is a property of a rectangle, so we're going to say rectangle, arrow, all right angles. And then after we declare right angles, what should we always say about the right angles? That they are, after we declare we have right angles, we should always say the right angles are what? Congruent. So now I'm going to say angle ADC is congruent to angle BCD. Right angles are congruent. All right, so we got an angle. Somebody get me a side. Looking at our triangles, let's get a side. Jerry? Excellent. Step number 4, we're going to say that AD is congruent to BC, and our reason is going to be rectangle, arrow, opposite sides congruent. Okay. Does anybody see another side? So we have a side and an angle. Does anybody see how I can get that last side to make it side, angle, side? Adrian? DC reflexive, you got it. DC congruent to DC reflexive. So now I can go ahead and say triangle ADC is congruent to triangle BCD, and that is going to be side, angle, side. Can I now see PCTC angle 1 and angle 2? Absolutely. So now I'm going to say angle 1 is congruent to angle 2. CPCTC. Then we can go on and say that DE is congruent to CE, and that's going to be base angles, 2 legs. And lastly, we can say triangle DEC is isosceles, def of isosceles. So those were 2 different ways we could have done this. All right, our last problem for today. I think number 3 is a great question. I think. So this is T and this middle point is A. I don't know why it didn't come out clear. Did it come out on yours or no? Okay. Okay, so I'm telling you VRST is an isosceles trapezoid, which means we can use all the properties of an isosceles trapezoid to help us out. Now we want to prove that VRA, oh, I thought this was a different question. It's still not bad though. VRA is congruent to TSA. We want to prove that these 2 triangles are congruent. I will tell you, we're not going to be able to prove these triangles congruent right away. The reason we're not able to prove these triangles congruent right away is because you know that the legs are congruent. You can do the vertical angles. Yesterday we spoke about how the top 2 parts are congruent and the bottom 2 parts are congruent, but that idea of the top 2 parts of the diagonals congruent and the bottom 2 parts of diagonals congruent, are we allowed to use that idea in proofs? No. So we wouldn't have that. So we would just have an angle and a side. So what are we going to have to do? Take a detour. So we need to prove a different pair of triangles congruent. All right, which triangles are you thinking of? Any ideas? Does it matter? Doesn't matter, they both work. Let's for fun, let's do these top triangles. Do you guys see that yellow triangle? And this triangle? All right, let's get those triangles. So, somebody tell me a property of an isosceles trapezoid that can help us here. Sam?
I'm not really sure, but I know it's something to do with the upper base and the lower base, I think.
The angles? Yeah, the upper base angles are congruent. So do you guys see this big angle V in the yellow triangle? That's going to be congruent to this big angle T in the purple triangle. So I need to name those angles with 3 letters. So angle RVT is congruent to angle STV. And our reason is going to be isotrap, arrow, upper base angles congruent. Okay, so we got an angle. Anybody see anything else we can get? The legs, exactly. So step number 3, I can say that VT and TS are congruent. Sorry, VR is congruent to TS. And the reason here is going to be isotrap, arrow, legs congruent. So now I have a side and an angle. Who sees how I'm going to get that last side? Who sees how I'm going to get that last side? No? Livy?
I was looking at the wrong chart. Wait, can you do reflexive in between?
Yeah, VT reflexive, absolutely. So step number 4, we're going to say that TV is congruent to TV reflexive. And so now I can say triangle RVT is congruent to triangle STV, side, angle, side. So now I need to CPCTC something from the yellow and purple that is also in the green. It's an angle. Does anybody see an angle that are in the yellow and the purple that I can also CPCTC for the green? Tanya? Good. Can I call them R and S? No. Can I call them 1 and 2? Absolutely. So I'm going to go and CPCTC angle 1 and angle 2. So this changes everything for us now. So look at what we have. We had that the legs were congruent. We have now angle 1 congruent to angle 2. Can I do now the vertical angles for 3 and 4? Yeah, and what does that make it? Angle, angle, side. Are we now allowed to use angle, angle, side? Yeah, we are now allowed to use, since section 7.2, angle, angle, side. So step number 7, we're going to say angle 3 is congruent to angle 4. Vertical angles are congruent. And then we can finally say triangle VRA is congruent to triangle TSA, angle, angle, side. All right, your homework is in the textbook. So we are done for today.